folks. Good afternoon, everyone. This is the first time that I'm coming up to speak, and I feel the music makes me feel like I'm coming up for a WWF match. So, yes, looks like it. And if I look like I've just walked out of a long-distance train, I've been traveling for the past 2 days, and last night's flight into Bangalore was from Bombay. For those of you who have been following the weather, it was not pleasant. So I think the flight was a few hours late, but fortunately, here I am. I teach AI, and I enjoy some of the luxuries that those in industry do not, in the sense of being able to dabble with concepts of AI. So the next few minutes, I hope to present some of the concepts in AI that we have been researching, partly a result of. So I have two buckets of research. One is theoretical, conceptual. That's what I'm presenting on today. And then there's the other applied side, where we focus on NLP. We dabble a little bit in computer vision and reinforcement learning, but for the most part, of late, it's been NLP, and more specifically, retrieval augmented generation. Today, I want to speak to you about the limits of artificial intelligence, and that's partly driven by the motivation that a lot of the failures in AI, a lot of the misses and faults, AI faults, have been a result of people not understanding the limits of artificial intelligence. Okay. All right. So what I'm doing as a matter of habit is looking at my screen and also moving, so it's like two sets of slides. So pardon the awkward pauses in between. The outline for today's talk is, first, a quick reflection on the concept of AI. Second, the concept of generative AI. And then, hopefully, I'll travel pretty quickly to talking about the limits. A quick warning, and that is, so what you're seeing out here is a 3-hour lecture that I give to my students once a week as a part of my 1 semester-long course on artificial intelligence strategy. So I'll try to be brief. I'll jump across certain slides, and hopefully all of it will come together towards the end of today's session. So what is AI? Well, AI is everywhere, and most of the people, including those in industry, have a perspective on AI based on the applications they're developing, or the industry they're working in, or some kind of exposure to AI. And I have of late begun to divide the world into two categories. One is the post-GPT AI scientists, AI professionals, and AI companies, and the pre-GPT AI professionals, AI scientists, and AI companies. So I come from the pre-GPT, pre-chat GPT category of AI professionals. And there was a time I remember when I would tell folks that I'm working with NLP, I would get the strangest of looks, and nobody really wanted to have a cup of coffee with me because they didn't want to be a part of the conversation about algorithms and artificial intelligence. Now, there are numerous definitions of AI. So some of the more prominent classical ones, especially from an academic perspective, is that AI is a collection of technologies, mathematical and statistical models, and a vast array of diverse types of data. And the key part there is that seeks to model or exceed human intelligence capabilities. And then we have this whole challenge of what is intelligence, and more specifically, what is human intelligence? These are not questions that have been fully answered. So when we speak about artificial intelligence, and we are pegging what we are calling as AI to human intelligence, that's where it all started off in the 1950s, when the so-called fathers of AI, McCarthy and Turing and others, they said that we got to create machines where the output of these machines should be comparable to the output of human intelligence. And they were specifically not concerned with the how, which means how does the human intelligence work versus how does AI work. That was not their concern. Their concern was that the output that machines produced should be comparable to the output of human intelligence. And most of what we see today is based on that ideology that was established or that was set into motion at that point of time. And I often wonder what the world would look like today if the term artificial intelligence had not been coined. There's also this question of what is not AI. Is a watch an AI? Is a magnetic compass an AI? So if the definition is limited to a machine or a tool that can perform a certain intellectual task better than human intelligence, then if you're lost in a desert or in a forest at night and it's a cloudy sky, the magnetic compass is going to provide more intelligence on the direction than you possibly can with human intelligence, even if you're a very educated person. So is the magnetic compass artificial intelligence? I think most definitely not. And the same goes for the mechanical watch. I'm not talking about the smart watches of today. But if we think about the mechanical watch, you wake up in the middle of the night, you don't know what the time is, you look at your watch, it tells you it's 2:43 a.m., and if it's working properly, that is what the time is. It provides you with more intelligence than what the human intelligence can. So that alone cannot be a definition of AI. Sophistication alone also cannot be pegged as AI. And this is important because today, in our observation, we are tracking a lot of companies, we are tracking a lot of applications, trying to focus on the more interesting ones. But what we see is there are a lot of companies which are doing, for example, some variation of regression, multiple regression or something, and the claim is they're using AI. No, they're using statistics. And then there are others who are using a classical optimization, linear optimization, find a deterministic solution. You've got a great array of solutions. It is the best solution. And for those of you with a supply chain or logistics background, you know that optimization is the way to go if you want the best decisions, especially in deterministic scenarios. But that by itself is not AI. But because AI is the in thing, it's fashionable, it attracts investments, all kinds of things are being called as AI. I think we need to be careful there as to what we call AI. So coming closer to a conceptual definition, I think one of the definitions that we felt was fairly representative is AI is a set of technologies. It's not a single technology, it's a cluster of technologies. It embraces everything. If you go to medicine, it's going to embrace medical technologies. If you're talking about the stock market, then it's going to embrace the entire market microstructure. So it's a cluster of technologies that mimic the functions and expressions of human intelligence, specifically cognition, learning, and logic. So, for example, going back to my arguments from a few seconds or a minute or two ago, the magnetic compass does not learn. So, all right, we can say the learning component is missing, so maybe that by itself could be a clue that we need not categorize it as AI. So if we look at cognition, which is the ability to see, such as computer vision, hear, and different kinds of sensory capabilities, logic, the ability to apply, to identify patterns, to apply equations, so on and so forth. And then the whole idea of learning. And we could stretch this up into adaptivity and a few other things, but we wanted to keep it simple, and we felt that we could argue that cognition and logic were, as broad umbrella terms, encompassed everything else that we wanted to include. Like I said, I'm a 3-hour speaker, so let me keep my watch in front of me to clock the time. What is generative AI? This slide is usually about 30 minutes by itself, but it's a class of AIs that can produce digital and material. Thank you. So you have not been seeing these slides. Thank you for waving out. This is where I spoke about AI being everywhere. This is what is AI, and this is what is not AI. That's the effect of not sleeping last night. At least I have something to push the blame on. And this is the slide on what AI is. And that's the red highlighted definition that I just read out, AI is a set of technologies that mimic the functions and expressions of human intelligence, specifically cognition, learning, and logic. And finally, this is where we are. Gen AI is a class of AIs that can produce digital and material output. I put create in inverted commas because it's an open debate as to if generative AI is creative or not. I think if our measure of evaluation is purely the output, what's the output that a human brain can produce, and what's the output that AI can produce, then I think we would be compelled to conclude, at least to some extent, that AI is increasingly creative, whether it's in image generation, whether it's in text generation, whether it's music. But then again, like I said, it depends upon the definition of what you call as creativity. So if you go back to the process of creativity, how do human beings create? There are some parallels between human intelligence being creative and AI being creative. So if you give a task to a kid to draw certain objects or certain scenarios, and if the kids draw it quickly and they're creative in terms of calling different elements, arranging it in an interesting and original manner, then we say that kid is creative. That's a good drawing. If we apply that same standard, AI is creative. But if we were to talk about imagination, then we are suddenly getting into different territory. Because humans, especially kids, and adults too, but kids, they have the time and space, and they have the motivation to imagine to levels that adults often may not. Then suddenly AI becomes very distinct from how human intelligence works. For AI, it's a matter of the data that it's stored as small, tiny bits of information or tokens of information. And then, when it receives some kind of external stimuli, you may have a prompt, you may have a set of one or more queries, it finds the best probabilistic match. And what you see is probabilistic output. It has no sense of joy over a sunrise or a sunset. It just produces probabilistic output. But when a human being produces a picture of a sunset or a sunrise, there is emotion associated with it, there could be imagination associated with it, there could be elements that are introduced in the picture which are not based on past data, arguably, again, that's arguable, but are not based on past data, but something completely based on really stretched out imagination. So there's some differences out there, and depends upon what we do. Now, the generative AI, the output can be digital and material. In the early stages, I only put digital, and then as we brainstormed, as we did more work, think about this. Whatever generative AI is producing in terms of images, if you connect it to a 3D printer and get it to print it out, you suddenly have transitioned from generative AI producing digital output to material output, and many such applications. A few images just to talk about how generative AI works. So this is an app called as a spiral app. I'm getting better at this. The spiral app, it's an image generator, and the only thing it does is it applies spiral patterns to images that it gathers based on your query. Now, if a human being were to produce such an art, and let's say this is AI produced, but if this were not to be AI produced, and let's say a human artist created this, I think most of us would attribute some value to it. Some of us might find it to be artistic, but whatever it is, we would say, this is interesting, this is intellectually stimulating, so on and so forth. While this is a very simple, this is something that a computer science student could design. This is a spiral app. You could kind of use other patterns instead of the spirals. So my point is, for the AI, especially a narrow AI, you can create a range of such AIs, and the AI is always going to follow a pre-specified pattern or a pre-specified approach to generating probabilities. This is an image, by the way, that I generated, and that's the app. I'm not sure if it's still working, but for those of you who are interested and want to give it a shot, that's spirals.versal.app. Just interesting stuff to play around, and I always encourage my students, the best way to learn AI is to actually engage with applications and the concepts simultaneously. Next, what motivated all of this background information about what is AI, what is generative AI, what's an example of what a simple, narrow, generative AI looks like, is the fact that we are seeing tremendous amount of what we are calling as fails, where AI is simply failing, AI is simply missing the mark, AI is hallucinating, and in some cases, AI is causing significant damage to the reputations of companies. And if it's a startup, startups are closing down because what they attempted is not happening. And they're kind of running out, they're burning up investor money, and it's not working out well. And it's not just small companies or mid-sized companies. Some of the companies who have failed in using AI are very large companies who can hire and have hired the best of resources, the best of computer scientists, and yet they have attempted and failed and rolled back multi-million, very, very, very expensive projects. McDonald's being one of the companies that rolled back its product after things went terribly wrong, and social media made it go viral. So when we get into the space of saying, let's create an AI to do X, Y, Z, most of these initiatives are based on some kind of an understanding of the capability of AI. People are aware of how to use computational algorithms for computer vision, for text generation, for foundation models have been a game changer. Especially now we're working on multimodal foundation models. It's amazing. Now, I was involved, for example, in text generation with small language models way before, from the times of BERT, for those of you who have been following the language model development space. And then GPT came along, and ChatGPT came along, and everything came into public view. And that spurred so much interest that people began to rush into the AI applications development, AI company startup space, without really understanding, okay, we're using computer vision, but what's the limitation of computer vision? We are using text generation, but what's the level of accuracy that we can expect? And conceptually, philosophically, especially for those who have been studying computational linguistics, we know there's an extent to which we can computationally represent human language and the expression of human language. It's temporal, it changes from time to time. So for example, one of the things that we do is track trends on social media and how machine learning algorithms change. The output of machine learning algorithms, the parameters change based on these trends. The meaning of the word airport, very simple word, everyone understands it, should be fairly easy for a language model to use it, but the meaning changed when the US forces were pulling out of Afghanistan, and there was this whole issue with what was going on there at the Kabul airport. Suddenly, social media was filled with airport images of things going wrong at the airport. It was a trending thing, and that distorted the AI associations with the word airport for those AIs which were using data from that segment of time, and many such scenarios. So that means if you want to successfully create AI applications, you need to have a firm understanding not only of the high potential that AI has in terms of its capabilities, what you can do with AIs, which is what is overwhelming most of our minds at this point of time, but you also must be aware of what is it that AI cannot do, or what is it that we have to be careful about when we are engaging AIs. I think I'm at 1:57, so I'm going to try to go really fast to get this by about 2:02. Number one, most important thing, if you were to ask me, what's the one single thing that you would want us to take out of this session? That's the first point there. Artificial intelligence does not have an intrinsic sense of meaning. no matter how nicely it answers your questions, no matter how verbose it is, 100 words, 200 words, 500 words, it does not matter. The point is it does not have an intrinsic sense of meaning in the same way that human beings have. Second is dependent on training data, low quality Gen AI output. And this also goes, think about this for those of you who are using different kinds of machine learning and deep learning with the assumption, there's this famous quote from Albert Einstein, and he said that if you do the same thing over and over again and expect to get different results, it's a form of madness. Now, how does it relate to machine learning? If you do the same thing over and over again and there's no significant difference in the new data that's coming in, then it's madness. Your results will remain the same. Your static model will give you the same result as the result after you run some very expensive to run machine learning models. If your data is good and improving and providing new information value, then your machine learning models will improve and lead to better results. But there's also the likelihood that the information contained in the new incoming data is worse than what was available previously. You may just get wrong signals, in which case your ML models can actually lead, potentially, if you have not implemented safeguards, to worse output. In other words, the assumption that you keep running ML models and it'll lead to that it'll always lead to improved output, that's not a I would say, safe assumption. AI can be manipulated by its creators, and one of the greatest dangers is the moment we say AI has bias, which I say too, and then you try to fix it with manipulations, you're getting into a very dangerous space where those who create AIs have a lot of control in terms of what you see and eventually what you will believe about products, about politics, about just everything of worth. So be very careful about getting into that space. And unfortunately, a lot of the regulations that we are seeing, it's the kind of regulations that big corporations like. It's not the kind of regulations that protects people, small companies, startups, so on and so forth. So we would like to see regulations. I've been calling for regulations for quite some time, written about it, but we are not seeing the kind of regulations that should be there. Like if you create a small product, if you create a piece of soap, the government requires you to write everything that's gone into that soap. But for AIs, no government has mandated that you have to specifically specify every bit of information that's gone into it, raw data that's gone into it, what are the algorithms that are used. That should be public knowledge. If we are going to engage such powerful technologies, what's gone into it should be public information. But it's not there, at least not yet. Bias, we all know about it. Legal and regulatory challenges associated with the complexity of this space. Extreme types of unpredictability. Now, even in statistics, data science, basically in all of science, there is a small measure of unpredictability, but the kind of unpredictability we are seeing with AI is unprecedented. Other limits. The future. So what's the solution? Adaptive. AI learns from and about and adjusts. We have been saying this for quite some time. Augmentative. Not only should AI be adaptive, which means it learns from interacting with humans in particular, learns from interacting with its environment, but also we must design AIs to optimize and maximize human performance. And that, the moment we speak about maximizing human performance, we are getting into the enhansive space, which is where my research is currently focusing on, in human and artificial intelligence interaction, where what we are talking about and the frameworks that we are developing focus on AIs that are designed to maximize human performance, not stopping at human performance, but also the fact that ultimately the human being is just not a work machine with KPIs. So far, the AIs that we are creating are like, even if when we speak about human engagement, it's about the KPIs or some kind of metrics should be maximized. But it goes beyond that. We're talking about satisfaction, and we're talking about holistic success for all stakeholders, not just for those who are using the AIs, but those who are at the receiving end and society at large. 202, I'll skip that. Bottom line is, this is not an argument against the opportunities of AI. Tremendous opportunities in AI, and we must seize them. I would say that we are not seeing sufficient activity to seize the true potential of AI, but we need to be aware of the limits. That's the only argument that's being made. So what are some of the takeaways? Number one, ID the limits of AI. Number two, fascinating possibilities with AI technologies, even after marking the boundaries. So when we say limits, these are not going to limit your opportunities, but rather they will decrease the risks associated with the opportunities that you're already pursuing. It frees you up to engage and leverage the real factual potential of AI. And finally, it will lead to fewer misses, fails, and ruins with AI. A summary of the key concepts: AI is probabilistic. Do not presume that AI can understand meaning or has any sense of intrinsic meaning. There is no artificial intelligence technology right now that has this. AI applications do not ascribe personality. I should not use do not. I would say it's unwise to ascribe personality. This slide needs edits. AI models, it's unwise to attribute identity. See, these are things in our imagination. When an AI is presented, which talks like a human being, it smiles, it's like an illusion that's being created. The AI is simply a probabilistic machine depending on foundation models, reinforcement learning, and a few other technologies. It does not have identity. It does not have personality. That's in our imagination. And as creators, as thought leaders, as people who are in this space, we need to understand this and we need to be careful because the consequences can be significant. Artificial general intelligence and singularity and such concepts, I know that OpenAI and others are working hard on this, but they're near impossibilities with currently known technologies. If quantum computing or some other presently unenvisioned technologies that we're completely unaware about, if they evolve in the future, then maybe I'll revisit this. But as of now, I think I can get into a debate with anyone and prove that AGI and singularity are fascinating concepts for movies and the like, but nowhere close to it. So, wishing you all success with your AI endeavors and initiatives. Hope that you understand the potential and the limits of AI. Focus on narrow AIs, domain-specific, application-specific, and I think that's the path to success. Thank you all for your patience, and I think I'm done.
Thank you very much. We have time